This is the 2018 MEXT Special Training College mathematics paper. Let's begin. Section 1, number 1, log base 5 of 0.008. 0.008 can be expressed as 8 times 10 to the power of minus 3. And recall that log base a of b times c is log base a of b plus log base a of c. Therefore, now here's another rule. Log base a of b to the power of c is c times log base a of b. 8 is 2 cubed, and using this same rule, log base 5 of 8 or log base 5 of 2 cubed can be rewritten as 3 log base 5 of 2, and 10 is 2 times 5. Log base 5 of 10 is log base 5 of 2 times 5, which is log base 5 of 2 plus log base 5 of 5, and log base a of a is 1, so this becomes 1. These two terms cancel out, so we are left with minus 3. We have the sixth root of 16 cubed. This can be rewritten as 16 to the power of 3 over 6. And 3 over 6 is a half, so 4 is the answer. Number 2. We have sine 75 degrees plus sine 120 degrees minus cosine 150 degrees plus cosine 165 degrees. Sine 120 degrees is root 3 over 2, and cosine 150 degrees is minus root 3 over 2. And we have a minus sign here, so let's flip the sign. 75 can be expressed in terms of 30 and 45, and 165 is 45 plus 120. So sine 75 degrees is sine 30 plus 45 degrees, and cosine 165 degrees is cosine 45 plus 120 degrees. And let's use the angle addition formulae. Sine alpha plus beta is sine alpha cosine beta plus sine beta cosine alpha. And cosine alpha plus beta is cosine alpha times cosine beta minus sine alpha times sine beta. Therefore, now sine 30 degrees is 1/2, and cosine 45 degrees is root 2 over 2, and sine 45 degrees is also root 2 over 2, and cosine 30 degrees is root 3 over 2. So sine 30 plus 45 degrees is root 2 plus root 6 over 4. Cosine 45 degrees is root 2 over 2. Cosine 120 degrees is minus 1/2. Sine 45 degrees is root 2 over 2. Sine 120 degrees is root 3 over 2. So cosine 45 degrees plus 120 degrees is minus root 2 minus root 6 over 4. So let's add them all up. These two terms become root 3, and these two terms cancel each other out. So we are left with root 3. Number 3. First of all, let's do some prime factorizations. 3 times 6 is 2, 3, 3. So the common denominator will be 2 times 2 times 3 times 3 times 3 times 5. So this one is missing 2 times 3 times 5. And this one is missing 2 times 5. And this is missing just 5. And this is missing 3. So 48. 48 is... So the answer is 4 over 45. Number 4. We have an inequality, so let's begin with this part. When you're dealing with inequalities, it's always a good idea to draw a quick sketch, and this has to be less than 6. So x should be between this point and this point. So let's substitute 6 into y and solve this equation for x. We have minus root 6 and plus root 6. Now x is an integer. So what integers lie between these 2 points? Root 6 is between root 4 and root 9, which are 2 and 3 respectively. So root 6 is 2 point something. So the integers between these 2 points are minus 2, minus 1, 0, 1, and 2. So the integer x is between minus 3 and 3. And now let's shift our focus to the left half of the inequality. When x is minus 2, minus x becomes plus 2 and x squared becomes 4, which is true. When x is minus 1, minus x becomes 1, x squared becomes 1. This is false. When x is 0, minus x becomes 0 and x squared becomes 0. This is false. When x is 1, minus x becomes minus 1 and x squared becomes 1, which is true. When x is 2, minus x becomes minus 2 and x squared becomes 4, which is also true. So we have 1, 2, 3 integers. So the answer is 3. Number 5. We have a 4-digit integer, and each digit is a different number, and this number is greater than or equal to 5,000. Let's begin with the thousands place. A can be either 5, 6, 7, 8, or 9. So we have 5 choices. And B can be either 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. But recall that when we chose a number for A, we picked one of these 5 numbers. So we need to subtract one number from these 10 numbers. So we have 9 choices. And for C, we have 9 minus 1, 8 choices. And for D, we have 8 minus 1, 7 choices. So 5 times 9 times 8 times 7, which is 2520, and this is the answer. Number 6. We have vector A plus vector B plus vector C equals 0, and the magnitude of each of these vectors is 1. When the sum of vectors equals 0, that means that we are going back to the origin, like this. So we have a triangle, and the second statement tells us that we have an equilateral triangle with the side length of 1, and each angle is 60 degrees. And we need to find the angle between vector A and vector B. So let's move vector B over here. This angle was 60 degrees, and this angle was also 60 degrees. So the angle between these two vectors is 120 degrees. And next we need to find the magnitude of vector A minus vector B. Vector A plus vector B would be this vector. Now let's flip vector B in the opposite direction, and we get, and then move vector minus B here. So vector A minus vector B is this new vector here. And given that the angle between these two vectors is 120 degrees, and both vectors have the magnitude of 1, we have an isosceles triangle, 30 degrees. Since we know the lengths of two sides and the angle between them, we can use the cosine rule to figure out the magnitude of vector A minus vector B. So cosine rule states that length C is root A squared plus B squared minus 2AB cosine theta, where theta is the angle between A and B. The magnitude of vector A minus vector B is root 1 plus 1 minus 2 times 1 times 1 times cosine 120 degrees, which is minus 1/2. So now we have the answer. The magnitude of vector A minus vector B is root 3. Number 7. We have a progression 3, 4, 6, 10, 18, and so on. For part 1, we need to find the 8th term. And for part 2, we need to find a term that is equal to 1026. Let's try to figure out the pattern that underlies this progression. The difference here is 1, the difference here is 2, and the difference here is 4, and the difference here is 8. So the difference doubles each time. Based on this information, let's try to find the general term. Because we are adding something each time, we have a plus here. What's being added is a multiple of 2, so 2. And between the first term and the second term, the difference has to be 1. So how can we make 1 out of 2? 2 raised to the power of 0 is 1. So we need to have 2 raised to the power of n minus 1. This will become 1, and to get 3, we have to have 2 here. And this is the general term. The 8th term is 2 plus 2 raised to the power of 8 minus 1. Now 2 to the 7th power is 128, so the answer is 130. Next, which term is going to be equal to 1026? What are the prime factors of 1024? So we have 5 and 5. So 1024 is 2 raised to the power of 10. Therefore, minus 1 is 10. So n is 10 plus 1, the 11th term. Number 8. We have a function f of x equals x squared minus 4x plus 1. And for part 1, we need to find f of minus 2. So let's substitute x equals minus 2 into the function. The answer is 13. And for part 2, we need to solve x squared minus 4x plus 1 equals 0. And let's use the quadratic formula. So x is 2 minus root 3 or 2 plus root 3. For part 3, we need to find the area bounded by the curve and the x-axis. But first of all, let's try to visualize what's going on in this question by drawing a quick sketch. The area is under the x-axis, so we need to remember to put the negative sign in front of the integral. This is going to be a very tedious calculation, so I'm just going to tell you how to open the squared brackets and skip right to the solution. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. And a minus b cubed is a squared minus 3a squared b plus 3ab squared minus b cubed. The answer is going to be 4 root 3. Number 9. We have 3 points ABC in a 3-dimensional space, and we need to find the area of the triangle formed by these 3 points. You can use the following formula to calculate the area of the triangle. The formula says the area is equal to 1/2 times the magnitude of the cross product of vector AB and vector AC. So first of all, let's figure out vector AB and vector AC. The x component of vector AB is the x component of B minus the x component of A, the y component of B minus the y component of A, z component of B minus the z component of A. So vector AB is -1, -2, 1. Likewise, let's find vector AC. And now, let's find the cross product of the two vectors. Let's use this 3×3 matrix by finding the determinant. To find the x component, we focus on the y column and the z column. The determinant of a 2×2 matrix like this is A times D minus B times C. So -2 times 0 minus 1 times 2, which is -2. So the x component is -2. To find the y component, we focus on the y column and the z column. -1 times 0 minus 1 times 2, which is -2. Y component is -2 as well. To find the z component, we focus on the x column and the y column. -1 times 2 minus -2 times 2. -2 plus 4, which is 2. So the z component is 2. The magnitude is the square of the x component plus the square of the y component plus the square of the z component. 4 times 3, root 12, which is 2 root 3. So the area is 1/2 times 2 root 3, which is root 3. And this is the answer. Section 2. In this question, we have a quadrilateral ABCD inscribed in a circle. In part 1, we need to find the radius of the circle. BAC is 60 degrees. We also know that BDC is 60 degrees. And because BD and DC are equal in length, the triangle BCD is an isosceles triangle. This means that these two angles at the base are equal. That means we have 60 degrees and another 60-degree angle here, which makes the triangle BCD an equilateral triangle. And we also know the length of each side to be √3. So the radius r would be this length here. Let's extract the triangle BOC. The angle here is 30 degrees, and we have another 30-degree angle. The angle here is 120 degrees. And the length BC is, of course, √3. And to find the radius, we can use the sine rule, which says that A over sine A is equal to B over sine B, which is also equal to C over sine C. So R over the opposite angle, sine 30 degrees, is equal to √3 over the opposite angle, sine 120 degrees. Now, sine 30 degrees is of course 1/2. Sine 120 degrees is √3 over 2. So the radius r is 1. In part 2, we need to find the length of AC. From the fact that CBD is 60 degrees, we can deduce that CAD is also 60 degrees. This means that AC is the angle bisector of the angle BAD. This also means that the angle here is 90 degrees, which also implies that AC is the angle bisector of BCD. AC is the diameter of the circle. So AC is 2r, 2 times 1, so the length of AC is 2. In part 3, we need to find the angle BDC, which we already know to be 60 degrees. In part 4, we need to find the area of the triangle BDC, the equilateral triangle. We know that the base of the triangle is √3, then what is the height of the triangle? The length here is 1/2 of √3. We can calculate the height using the Pythagorean theorem. So the height of the triangle is 3 over 2, and don't forget to multiply by 1/2. So the area is 3√3 over 4. In part 5, we need to find the scalar product of vector DC and vector CA. The scalar product of two vectors is defined as vector A dot vector B equals the magnitude of vector A times the magnitude of vector B times cosine theta, where theta is the angle between the two vectors. What is the magnitude of vector DC? The length of DC is √3. What is the magnitude of vector CA? The length of AC is 2. Next, let's find the angle between the two vectors. Let's visualize the vectors. Vector DC is going from D to C, and vector CA is going from C to A. And the angle here is 30 degrees. The angle here must be 30 degrees, which means that the angle ADC is 90 degrees. And let's draw a vector here which is parallel to vector AD. The angle here must be 60 degrees. And now let's move vector CA here, like this. The angle here is 90 degrees, and the angle here is 60 degrees. So the angle between the two vectors is 150 degrees. So what is cosine 150 degrees? Cosine 150 degrees is minus root 3 over 2. So the scalar product of vector DC and vector CA is root 3 times 2 times minus root 3 over 2, which is minus 3. And this is the answer. Section 3, which is the last section. For part 1, we need to find whether a is greater than or less than 0. This should be easy. The graph is facing downwards. This means that the coefficient of x squared must be negative. A is less than 0. Part 2, we need to figure out whether 4ac minus b squared is greater than or less than 0. 4ac minus b squared is very similar to the discriminant b squared minus 4ac. Recall that the discriminant is positive if the parabola has two roots. Now 4ac minus b squared is minus b squared minus 4ac. So this has to be negative. In part 3, we need to find whether a plus b plus c is greater than or less than 0. What you need to realize is that a plus b plus c is the value of y when x is 1. So let's look at the graph. When x is 1, the y value is negative. So a plus b plus c must be negative. In part 4, we have 4a minus 2b plus c. This is equivalent to substituting x equals minus 2 into the equation of the parabola. When x is minus 2, the y value is definitely negative. In part 5, we have c over a. If the two roots of the parabola are alpha and beta, then the product of the two roots is equal to c over a. The first root is between 1 and 2, and the second root is definitely greater than 2. Since both roots are positive, the product of the two roots must also be positive. Alpha times beta is positive, therefore c over a is positive. Next we have b over a. Recall that the sum of the two roots is equal to minus b over a. Alpha times beta is definitely positive. B over a must be positive. That means b over a is negative. Next we have b plus 4a. In the previous part, we saw that alpha plus beta is equal to minus b over a. The first root, alpha, is between 1 and 2. From looking at the graph, I think we can assume that the second root, beta, is greater than 3. So alpha plus beta is greater than 1 plus 3, or 4. So minus b over a is greater than 4. Now let's multiply both sides by a, but part 1 tells us that a is negative, so we need to remember to flip the inequality sign. So b plus 4a is greater than 0. And finally we have 2a plus b. This part can be solved following the same line of thought as in the previous part. The sum of the two roots is equal to minus b over a, and the first root is between 1 and 2, and the second root is definitely greater than 1. So alpha plus beta is greater than 1 plus 1, or 2. So minus b over a is greater than 2. Multiply both sides by a, and don't forget to flip the inequality sign. so 2a plus b is greater than 0. And this is the end of this exam paper. Please let me know if you have any questions or requests, and see you next time.